My name is Maher Damak. I'm a PhD student at MIT in mechanical engineering, and I'm working on eliminating chemicals waste in agriculture.
I'm Kripa Varanasi. I'm a professor in mechanical engineering, and my group works on interfacial phenomena. Maher is one of my graduate students, and in his thesis, we are working on eliminating agricultural runoff. If you think about it, in agriculture, there's a significant amount of chemicals, and these chemicals pollute our soils, pollute our water resources, and we are trying to come up with a new technology that can eliminate this problem. So how does it work?
So the problem now is that chemicals application in itself is very inefficient, and studies have shown that only 2% of applied chemicals end up on their intended target. One of the main reasons for that is that many plants, or most plants, are hydrophobic or water repelling, which means that when you try to spray chemicals on them, droplets bounce or roll off their surface and end up in the soil. Most solutions that have tried to address this problem in the past have relied on chemical techniques that do not really work because the phenomenon happens on such a small time scale. It happens so fast that those chemicals don't have time to act. Our solution is different, and it uses electrical charge. So we use charged polymers that can interact really fast during the interaction between those droplets and the surface and make droplets stick. We have shown that we can have up to 10 times more retention of these chemicals, which means that you can have the same effect with using 10 times less chemicals. The polymers we use are plant and animal extracts, so they are biocompatible and biodegradable. So how did this all start?
So we in our group, we work on a variety of slippery interfaces to interfaces where we can get media to stick. And when we were talking to a whole range of farmers, to people in USDA, as well as farmers around the world, we found that this whole point of pesticides actually sticking to plants is a significant sort of a problem. Apparently, only 2% of what is sprayed makes it to a target surface, and the remaining is lost to the environment. And that sort of became an important mission for us to come up with new technologies to be able to sort of address this problem. And I'm very happy to say that we are there, and we are excited to take this to the market.
So our mission here is to reduce or eliminate waste and runoff of chemicals, and this will first protect our water resources that are so valuable. Second, will improve health conditions for farmers and people who live in rural areas. And third, it can be a paradigm changer for economic paradigm changer for farmers, since pesticides and other chemicals are an important part of the production cost. So to take our technology to market, we are planning to commercialize it and to start a company. We are currently starting a large-scale field implementation with partners. And at this point, we look for support in terms of funding, in terms of partnerships for product development and commercialization, and finally to raise awareness in general about this problem. Thank you.
Thank you.